All right, so these are your warm-up questions. I am going to present this so you can see the whole question, and then I'm going to pause the video so you have a moment to check your answers. So you need to read the details very carefully. Remember, MCA test is all about are you reading and paying attention. So again, pause the video here, solve it, then come back. All right, so what the big detail here that you needed to notice is that this stands for 3 carats. That stands for 3 carats. Let's get this marker back into place there. All right, so each check mark stands for 3 carats. We want to know how many carats did Flopsy eat in 1 week. If you said 5, that answer would be incorrect because each stands for 3. Flopsy had 15 carats, which would have been a multiple choice answer had you had the opportunity to see that, but sometimes it's best to try and solve it without that information right there in front of us. All right, your next question is right here. Pause the screen. Okay, now that you are back, you have a dice numbered 1 through 4. It's only numbered 1 through 4, and it's rolled. And you have 1 coin that is tossed. Draw a tree diagram to represent the possible outcomes. This is what we were dealing with yesterday, struggling a little bit with. But what we have to do is say, okay, I have 2 different things happening here. I have a dice or die, and I have a coin. And on my die, I could get the numbers 1, 2, 3, or 4. And on the coin, my options are heads or tails. And it doesn't matter what I got on the first with the die. These are going to be all of my options over here. Heads, tails, heads, tails. So then my answers or my possible outcomes would be 1 with a head, 1 with a tails, 2 with the heads, 2 with the tails, so on and so forth. But you would want to list all of those out because those are all of my possible outcomes. How many are there? There are 8. 1, 2, 3, 4, 5, 6, 7, 8. Again, because this would be 4 possibilities here, 2 possibilities, either heads or tails there, and 4 times 2 was 8. Again, review, I'm going to move this on down. All right. Draw a tree diagram. Please pause it now. All right. Some of you may have made the mistake thinking this is exactly like yesterday, but what I want you to notice is that there were 3 main dishes instead of 2 appetizers like last time. 3 sides, and yet still 2 desserts. So what I need to start with here is my main. For my main, I have 3 different options. I can get the burger, the hot dog, or the salad. From there, I have my side dish. Again, my side dish does not depend on what I got for my main dish. So I could get all 3, fries, chips, and a salad. Now, this might be a fruit salad. You don't know what kind of salad it is because I know there's going to be someone who says, wait, on this last one, you're not going to have salad. But we could still have salad with fries, salad with chips, salad with salad. So who knows what kind of salad it was. After I have my main dish and after I have my sides, I still have my dessert. Whoops, dessert. So then with my dessert, even if I had burgers and fries, I could get cheesecake or ice cream. Here, I could get cheesecake or ice cream. And I could get cheesecake or ice cream. Here, same thing. And I just keep drawing it over and over again because it doesn't change. Yes, this is going to take a little bit more space on your paper, and that's okay. So my final outcomes to create my sample space, sorry, not spelled the best there, is going to be burger, fries, cheesecake, burger, fries, ice cream, burger, chips, cheesecake, burger, chips, ice cream, burger, salad, cheesecake, burger, salad, ice cream. These 6 options alone came from just that burger. I'm going to have 6 more options here and 6 more options there for a total of 18. Again, another way to find that would have been 3 main dishes times 3 side dishes times 2 desserts, which would have got me to 18. Hopefully you already checked your answers from yesterday's assignment and you have turned that into the bin. If not, pause and do that now. All right, today we're going to talk about the fundamental counting principle. Hopefully my device here, I see we have our notice there, lasts us throughout the rest of the video. Fundamental counting principle says that it's random. Each outcome is equally likely to occur. If something is random, it's equally likely to occur. Fundamental counting principle says this: if there are m ways to do one thing and n ways to do another, then for a combination, it's m times n of doing both. Go ahead and pause this so you can write that down. All right, welcome back. There is an example here at the bottom, just like we were talking yesterday about Jennifer and her different outfits that she could possibly have. We now have 3 shirts and 4 pants. And 3 times 4 would give me 12 different outfits. Again, I could create a tree diagram. Some of you may wish to do that. You're more comfortable, but you don't have to. All right, go ahead and read this, pause it, see if you can come up with an answer. All right, so the sample size. What are the options for me with a dime? Well, I only have 2 options. I have heads or tails. So there are 2 options here. What are my options with the penny? Again, I only have heads or tails. So there's only 2 options. So altogether, my sample space is going to be 2 times 2. There's 2 ways to do this one and 2 ways to do that one. So there would be 4 total sample spaces, 4 total outcomes in my sample space. I could create the tree diagram again to show that, but that's what you did on your homework yesterday. Go ahead and pause and try this one. Okay, so again, with my quarter, how many different ways do I have to solve if I have a quarter? 2, heads or tails. How many different outcomes would there be with my dime? Yet again, 2. And with my penny, yet again, 2. I would multiply all of these together, which is the same thing in this case as 2 to the 3rd or 8. If I was to create a tree diagram, I would find that there were 8 different ways to solve that. Jennifer has 3 skirts and 2 tops. How many different outfits could she wear? Again, pause. All right. If we came and we were to create the tree diagram, you would find that you would have 6 different options for this. 3 times 2 equals 6. A restaurant offers a choice of 3 types of pasta with 5 types of sauce. Each pasta entree comes with or without a meatball, very similar to what we had done yesterday in class. So again, what I want you to do is pause the video, see if you can come up with an answer. Okay, now that you're back, this one has stumped people in the past. So what do I have going on here? First of all, I have pasta. And with the pasta, how many options do I have? I have 3. Next, I need to multiply that by my options for the sauce. How many sauce options do I have? Well, 5. So I have a lot of kids who tell me the answer to this is 15, but that's not right because we still have this with or without a meatball. With a meatball is one option, without is another option. So I still have to now multiply this by meatball, and either I'm getting one or I'm not. There are 2 choices there. So now I need to multiply that by 2. My total answer here would be 30 different possible outcomes, creating a sample space of 30. All right. Don't pause. We need to talk about this for a second. For the 2007 Major League Baseball All-Star Game, 14 players were nominated for each position in the infield. 14 were nominated for first base, 14 were nominated for second base, 14 nominated for shortstop, 14 were nominated for third base, and 14 were nominated for the catcher in the American League. How many different infield teams are possible when one player is selected for each position? So just like we had pasta, sauce, and meatball, this time what we're going to have is first base, second base, third, short, catcher. I think I got them all. Let me just check. First, second, short, third, and catcher. Yep. How many did I have? This says there were 14 nominated for each position. So I had 14 here, 14 here, 14 here, 14 here, and 14 here. What do I have to do to figure this out? I have to multiply it. You're welcome, by the way, for not having to create a tree diagram of this one, because once you multiply all those together, you're going to find out that it is a rather large number. I believe it's around 70, if I did my math correctly in my head, but I'm not sure. You would multiply all those together. Oh my goodness, no, I'm totally wrong. It's way more than 70. I just did 14 times 5. It'd be 14 times 14 times 14 times 14 times 14. All right, you have 6 different books at home. You want to organize them on your shelf. How many different ways can all the books be positioned on the shelf? So you have to ask yourself, this one's a little bit different. Again, do not pause this. Here I have book 1. How many different books can I put here? Well, I have 6 books, so I can put 6 different books here. Book 2. I have 2 different ways I can look at this problem. However, if I already have a book here, now I only have 5 other options for books to go here because I already put one there. So I only have 4 different options for a book to go here. 3, 2, 1. And I would multiply all of those together. And that would give me my answer. All right. On an English test, a student must write 2 essays. For the first essay, the student must select from topics A, B, and C. For the second essay, the student must select from topics 1, 2, 3, and 4. How many different ways can the student select the 2 essay topics? I'm going to give you a hint. My hint here is first essay, and this one is second essay. Pause it and see if you can come up with an answer. All right, now that you have these solved, your first essay had how many options? 3. So I would have 3. My second essay had how many options? 4. I would multiply those together, and there are 12 different ways that I could potentially answer this problem. All right, you're picking a password. It has to be the length of 6 characters. The first 2 have to be letters, and the last 4 have to be numbers. How many outcomes are there? They can repeat in this case. All right, so we know it's 6 long. We know the first 2 have to be letters. The last 4 have to be numbers. I want you to go ahead and pause and try to solve this. All right, what I hope you notice is the first thing I do is I'm setting up how many different ways this might be arranged. In this case, I know it needs to be 6 long. So I'm going to go 1, 2, 3, 4, 5, 6. What else do I know? The first 2 have to be letters. So how many choices do I have for a letter? How many letters in the alphabet? 26 times 26. The last 4 have to be numbers, 0 through 9. Now, the mistake that many people make here is they put 9. But go ahead, count on your fingers from 0 to 9, and you're going to find out that there are actually 10 digits. And each one of these, because it could repeat, has 10 different options. I would multiply all those together and find out how many different ways I could make a character, a password of 6 characters. Ms. Heldstab is going to give a 5-question true-false test. How many different outcomes are possible for this test? Go ahead, pause this video, and come on back. Okay, the first thing you should have done to solve this is drawn out your 5 questions. Here's question 1, question 2, question 3, question 4, question 5. How many options do I have for question 1? Well, I have 2. It's true or false. How many do I have for this one? Same thing all the way down. Again, I'm just going to multiply all those together, and I should get 32. There are 32 different ways someone could answer this questions on this test. Find out what question is being asked and put that number on the first what? On the first side, on the left-hand side, the first number, the M. Determine how many options there are and put that on the second part, the second number. Multiply the 2 together. Okay, your homework is as follows, but what I want you to do is pause this and make sure you get it written down. Find the number question is asked by put that number in the first column and the second column. Go ahead and pause so the kids can write this down. All right, now that you're done writing it down, there is the remaining part of your homework. You will spend the rest of your hour completing that, and we will see you tomorrow in class. Have a great day.